Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about adding and subtracting polynomials. And we're going to simplify each expression. So if I was given this expression, 5p squared minus 3 plus parentheses 2p squared minus 3p to the third. Okay. Well, first thing I look, separated by parentheses, does this plus sign change anything? And no, it doesn't. It doesn't change. We're adding both of these together to these, right? We're trying to combine them all together. Inside each parentheses, there's no simplification. So now I'm going to kind of move on without the parentheses, and I'm going to rearrange this from our highest degree terms to our lowest degree terms. So our highest degree terms is a 3p to the third, so I'm going to put a negative 3p to the third first. Then we're adding a 5p squared. Then we're adding a 2p squared, that one. And don't forget, then minus 3. Okay? Now, make sure we have all terms. Always double check that. We have 1, 2, 3, 4 terms, and we have 1, 2, 3, 4 terms there. Now, the way I combine these, all right, or rearranged it, okay, I have my like terms now are p squared. I can combine them together. There's no p to the third, so I have negative 3p to the third here, plus 5p squared plus 2p squared is 7p squared. And we have a minus 3, and there we have it. We have our expression simplified. Can't be simplified anymore. So we're given found a negative 3p to the third plus 7p squared minus 3. A to the third, parentheses, minus 2a squared, minus, parentheses, 3a squared, minus 4a to the third. Okay. First thing I need to do is I'm going to distribute that minus sign across here. So I'm going to rewrite all these with plus and negative because I like that. So I'll have a to the third plus a negative 2a squared. And notice I got rid of my parentheses. I couldn't simplify them anymore. Don't really need that there. This minus sign gets distributed to the 3a squared, so we have now a plus a negative 3a squared. And don't forget, it needs to distribute to this one here. Negative, minusing a negative is adding a positive, 4a to the third. Now I'm going to rearrange from my highest degree to lowest degree terms. So we have a to the third plus 4a to the third plus a negative 2a squared plus a negative 3a squared. Notice I'm getting all my terms together. I have a to the third, then 4a to the third, then negative 2a squared, and then negative 3a squared. Now we combine our like terms. A to the third plus 4a to the third is 5a to the third. And then negative 2a to the second plus a negative 3a to the second is negative 5a to the second, or a minus 5a to the second. And there we go. We have our final answer here. It's simplified. It's 5a to the third minus 5a to the second. 4 plus 2n to the third, parentheses, plus 5n to the third plus 2. Okay? Well, since it's all addition and in each parenthesis, we don't have anything that we can simplify within the parentheses. At that point, we can eliminate our parentheses. So we have 4 plus 2n to the third plus 5n to the third plus 2. Now I'm going to rearrange and put in my like terms first. Okay? Our like terms together and my highest degree terms first. So we have the 2n to the third plus 5n to the third plus then 4 plus 2. Okay? I have all 4 terms together. I just rearranged using the commutative property and brought them all, all my n to the thirds to the left and on the right-hand side of my numbers, my constants. Okay? So now let's add our like terms. 2n to the third plus 5n to the third comes out to be 7n to the third. And 4 plus 2 is 6. And there we have it. We have our final answer. Simplified here, 7n to the third plus 6. 4n minus 3n to the third minus, parentheses, 3n to the third plus 4n. All right. First thing I want to do, I like to make things adding a negative. So this left-hand side here, we can't simplify that anymore. So I have 4n plus a negative 3n to the third. But then the subtraction sign, I'm going to distribute. So that's like adding a negative. So it's like, okay, adding a negative, distributing 3n to the third plus a negative 4n. So now I'm going to combine my like terms. I have everything addition. All right, I find it a little easier that way. Put my like terms together or rearrange them using the commuter property, like terms together, and I'll have my highest degree first. So I have this negative 3n to the third first, plus this one, negative 3n to the third, plus 4m, and then plus a negative 4n right there. Well, negative 3n to the third plus a negative 3n to the third is a negative 6n to the third. And 4n plus a negative 4n is just 0, right? 0. Don't need to write the plus 0, so we have 6n to the third, or negative 6n to the third, and there we have it. We have our final answer, negative 6n to the third. 3a squared plus 1, parentheses, minus 4 plus 2a squared, parentheses. Okay? So what I'm going to do first is I'm going to distribute that subtraction sign across. There's nothing I can do to simplify this parentheses, so I'm going to rewrite this to be 3a squared plus 1. And I'm going to distribute that minus sign across, so we have minus a 4, or plus, excuse me, a negative 4, and then subtraction here, plus a negative 2a squared. Okay, so we distributed that minus sign across. Make sure you do that. Okay. Now I'm going to rearrange my like terms together in my highest degree first. So 3a squared. Then I have another, negative plus a negative 2a squared. Then we have a plus 1 and a plus a negative 4. Okay. Now let's combine my like terms. 3a squared plus a negative 2a squared is just a squared, right? 1a squared. And then 1 plus a negative 4 is a negative 3, so we have a minus 3 here, same thing, right? Adding a negative, same thing as subtracting 3. And then we have a squared minus 3 as our final answer. 4 r to the third plus 3 r to the fourth, close parentheses, parentheses again, minus just r to the fourth. Why did I put 4? I don't know why I put 4. Just r to the fourth. So r to the fourth minus 5r to the third. Okay. So if I wanted to simplify this, we look at each parentheses, and I can't simplify within each of these parentheses. So I'm going to rewrite this at 4r to the third plus 3r to the fourth first. But now I'm going to distribute that minus sign, and I'm going to make it to adding a negative instead of subtracting, because I prefer that. So I have a plus a negative r to the fourth, distributing that across, and then distribute to this one. Minus a negative is plus a positive, so we have plus a positive 5r to the third. Okay, now I'm going to rearrange. There's a lot of 4s, a lot of 3s here. I'm going to rearrange with my highest degrees first. Okay, so 3r to the fourth, that one right there, plus a negative r to the fourth. Got that other one, that's the fourth. All the fourths are gone. Now I'm going to do the third powers. So we have plus a 4r to the third power right there, plus 5r to the third, the last one. Let's double check. 4r to the third right there, 3r to the fourth right there, negative r to the fourth right there, and 5r to the third right there. Make sure we got everything down. Now let's combine our like terms. 3r to the fourth plus a negative r to the fourth is a 2r to the fourth. Then we add here 4r to the third plus 5r to the third is a 9r to the third. And there we have it. We have our final answer. It's simplified. We have 2r to the fourth plus a 9r to the third. 5a plus 4 minus, parentheses again, 5a plus 3. Okay. Well, first thing I want to do is I look in both parentheses, and there's nothing I can simplify within each parenthesis. So now I'm going to rewrite this left side, 5a to the 5a plus 4. But now I'm going to distribute that minus sign. Distributing the minus sign, subtracting a 5a is the same thing as adding a negative 5a. And subtracting, we're adding a negative 3 right here, right? Just added that negative 3, okay? So now, by distributing that negative sign across, or minus sign really, right? And now I'm going to rearrange my like terms together, okay? Now highest degree first. Highest degrees are the a's, right? So I have 5a plus a negative 5a. Then we have a plus of 4, my constants, plus a negative 3. So let's look at it here. Okay, let's double check. We got all 4 down. 5a right here, 4 right there, negative 5 right there, negative 3. I think it has to. Combine our like terms. 5a plus a negative 5a is 0. Plus 4 plus a negative 3 is a 1. Now, 0 plus 1 is just 1. And there we have it. Good old 1 by itself. Make a little fancy 1 again. Okay? And there we have it. Just this one simplified to just be a 1. 3x to the 4th minus 3x minus, parentheses again, 3x minus 3x to the 4th. Okay, this one's tricky. There's a lot of 3's, a lot of x's, and a lot of minus signs. We gotta keep them in line, okay? I'm gonna convert everything to adding a negative because I like that. I find it easier. So I have 3x to the 4th. Let's take our time here. Instead of subtraction, plus a negative. Now, I couldn't simplify anything in the parentheses here, so I had no problem eliminating that. Now, I can't eliminate this right away, but if I distribute the negative across, I can. So distribute that minus, or subtraction there, subtracting a 3x, the same thing as adding a negative 3x. Distribute that to the 3x, and distribute again over here to the subtracting a negative 3x to the 4th, right? Double negative, so we have plus a positive 3x to the 4th here, okay? So now I'm going to rearrange putting my like terms together and my highest degree first. So 3x to the 4th right here, highest degree is the 4th power. This one here is plus a 3x to the 4th, highest degree, right? Now I have just the x's left. We have plus a negative 3x and plus a negative 3x, okay? So combine our like terms now. 3x to the 4th plus a 3x to the 4th is a 6x to the 4th. And then negative 3x plus a negative 3x is a negative 6x. So we can just put subtraction instead of plussing a negative, or plussing a negative, adding a negative, minus 6x right there. And there we have it, okay? We have 6x to the 4th minus 6x. Negative 4k to the 4th plus 14 plus 3k squared, and parentheses plus, parentheses, negative 3k to the 4th minus 14k squared minus an 8. Oof. A big one here, okay? So, first thing I need to do is I'm looking at it, okay? Is there anything within the parentheses that are like terms? No, all right? There's no like terms within the parentheses, so I can't simplify it. So I can rewrite this, and I'm going to rewrite everything as adding a negative because I find that easier. I don't need my parentheses that way. So I have negative 4k to the 4th plus 14 plus 3k squared plus a negative 3k to the 4th plus a negative 14k, right, that minus with plus a negative, squared plus a negative 8, okay? So now, I'm going to rearrange, just like we did the other ones, rearrange putting our like terms first and highest degree first. So I see mine to the 4th powers. Both of them had something to the 4th power. So I'm going to rewrite that first. Negative 4k to the 4th, and then plus a negative 3k to the 4th. We don't have anything to the 3rd power, but let's look to the 2nd power. I see a 3k squared. So we have plus 3k squared next. And then this one here is plus a negative 14k squared. Lastly, we're just left with our numbers here. All right, 14 and negative 8. So we have plus 14 and plus a negative 8. Okay, we wrote a lot down. Let's double check we have everything. Let's just go line out, term by term. Negative 4k to the 4th, right there. 14 was right here. 3k squared, 3k squared was right there. Negative 3k to the 4th, right there. Negative 14k squared, right there. And negative 8 right there. I went through all the terms. All of them were transferred down correctly. Okay, now we have our highest degrees first to our lowest degrees. So now let's simplify. Negative 4k to the 4th plus a negative 3k to the 4th is a negative 7k to the 4th. Then we have 3k squared plus a negative 14k squared is a negative 11k squared. Then 14 plus a negative 8 is a positive 6. Okay? So now we need to we'll simplify this a little bit. We're not going to simplify it. I don't really like to have plus and negative as my final answer. It's easier to simplify, like when I'm solving or simplifying. So we have negative 7k to the 4th. I'm going to rewrite this to be subtracting 11k squared plus 6, and there we have it. We have our final answer from this large big thing to be negative 7k to the fourth minus 11k squared plus 6. 3 minus 6n to the fifth minus 8n to the fourth minus, parentheses, negative 6n to the fourth minus 3n minus 8n to the fifth. Okay? Well, from here, I need to simplify this, and again, I like to have everything adding a negative. So I'm going to take everything in this parentheses and make that 3 plus a negative 6n to the fifth plus a negative 8n to the fourth. And your teachers might not like that technique. I find it easier for myself. It keeps everything in line. Now I'm going to distribute that negative across to all parts. And this one's tricky. So we have distribute the negative into negative 6n to the fourth. That's plus a positive 6n to the fourth. Distribute again to the negative 3n here. So two negatives make it plus a positive 3n. And distribute that negative over here as plus a positive 8n to the fifth. I find that if I make everything adding a negative and plus positive to everything addition, I find I don't make mistakes, or as many mistakes. We all make mistakes, right? I don't make as many mistakes, and so I do it that way, okay? So now I have everything written out with addition here. I'm going to put my like terms together in my highest degree first. So I see a fifth power is the highest one, right? Fifth power, so we have negative 6n to the fifth plus, right here, bring on this 8n to the fifth, 8n to the fifth. I'm rearranging using the commutative property. Now I have to the fourth powers, okay? And if you want to make a little mark on ones that you've done just underneath, that kind of helps, okay? Negative 8n to the fourth, negative 8n to the fourth. That one, I have this 6n plus 6n to the fourth right there. And then left with just a 3n, so we have plus a 3n right there, and then plus a 3. So now I want to combine my like terms, okay? Oh, plus 3, I marked that one. Let's just actually, before I do that, let's double check I have everything. 3 is right there, negative 6n to the fifth right here, negative 8n to the fourth right there, 6n to the fourth right there, 3n right there, 8n to the fifth right there. Fantastic. And all of them have dots on it, kind of a way to double check, make sure I brought everything down. Now let's combine our like terms, highest degrees first, so negative 6n to the fifth plus 8n to the fifth is 2n to the fifth. Negative 8n to the fourth plus a 6n to the fourth is a negative, plus a negative 2n to the fourth. Then we have just the plus 3n left, 3n plus 3. Now I'm going to rearrange this. I don't like to have plus and negative. I'm going to make it subtraction. So we have 2n to the fifth minus 2n to the fourth plus 3n plus 3. And I only like it to be a subtraction in my final answer. When I'm simplifying, I like to add a negative. And that's just my own personal preference there. And there we have it. We have our final answer here of 2n to the fifth minus 2n to the fourth plus 3n plus 3. Parentheses, 12, a to the fifth minus 6a minus 10a to the third, parentheses, minus 10a minus 2a to the fifth minus 14a to the fourth. Okay? Well, so what I want to do now, okay, is I'm going to simplify this. Now we're looking at each parenthesis, and we see that, oh, we can't simplify there, so I can't do that now. So what I'm going to do is add a, take all these subtraction signs and add a negative. So I have 12a to the fifth plus a negative 6a plus a negative 10a to the third. Then I'm distributing now the subtraction sign across. So we have plus a negative 10a right here. Then this one here, distribute across plus a positive, negative, negative, positive 2a to the fifth. And distribute the last one here, plus a positive again, plus a positive 14a to the fourth. That's probably the most common thing I see from students is they don't distribute that subtraction all the way across. They distribute to the first term, and that's it. It needs to be to all parts because they're in that parentheses. So now I have all 6 terms here. I need to rewrite them highest degree first. Okay, highest degree, I see is to the fifth power. Take note of that. So I have 12a to the fifth, and I put a little dot saying that I've brought that one down. Then in this one here, plus 2a to the fifth. See that one? And I don't see any more to the fifths. So now the next highest degree is to the fourth power, 14 plus 14a to the fourth. So we have plus a 14a to the fourth right there. That's an a, not a 9. Mark it. Now, okay, I have the fourth power. What's the next highest power? IC to the third. So we have plus a negative 10a to the third power. Got that? Fantastic. So now let's bring the next highest ones I see are just the a's. So we have plus a negative 6a right there, and plus a negative 10a right there. Okay. So now let's go combine our like terms, or let's double check and bring everything down. Every single one of these terms has a dot, so we should have brought it down, but it's good to double check. 12a to the fifth right there, negative 6a right there, negative 10a to the third, fantastic, negative 10a right there, 2a to the fifth right there, and 14a to the fourth right there. Good. Now let's combine our like terms. 12a to the fifth plus 2a to the fifth is 14a to the fifth, plus, there's no other a to the fourth power, so we have 14a to the fourth. Okay, that's not that a. I'm not raising it. It's a pie sponge. And then this plus negative 10a to the third, nothing to combine it, so we can rewrite that to be minus our subtraction, right? 10a to the third. And then negative 6a plus negative 10a is a negative 16a, so that's a minus 16a. And so now we have our final answer here. 14a to the fifth plus 14a to the fourth minus 10a to the third minus 16a. 8n minus 3n to the fourth plus 10n squared, parentheses, minus parentheses, 3n squared plus 11n to the fourth minus 7. Okay? So, what I'm going to do first here is I'm going to make this parenthesis here, that subtraction, adding a negative. And now we can't, there's nothing to simplify over there, so I can rewrite it without the parentheses, 8n plus a negative 3n to the fourth plus 10n squared. And if you watch my videos, I prefer adding a negative. Okay? So now I'm going to distribute this subtraction sign across, and in doing so, I'm going to make everything to be add a negative. So, so subtracting 3n is adding a negative 3n squared. Then distribute the minus sign over here. We have plus a negative 11n to the fourth. And do it again over there. Two negatives makes a plus a positive 7. So now my next step is I'm going to rearrange, using the commutative property, all my highest degrees first. So I have negative 3n to the fourth. Fourth degree is the highest ones I see here. Put a dot there to mark that I've brought that down. Negative 11n to the fourth here, so I have plus a negative 11n to the fourth. Put a little dot right there, show that I brought that down. Now the next highest degree is the second power, so I'm going to add a 10n squared. Dot right there, and plus negative 3n squared here, put a dot right there. Then the next highest degree is just the 8n, so we have plus an 8n here. Boom. And then plus a 7 at the end. There we go. Let's double check we had everything down. We should by using the dot system, but 8n's right there, negative 3n to the fourth right there, 10n squared right there, negative 3n squared right there, negative 11n to the fourth, fantastic, and 7. And we just double check highest degrees first, fourth power, second power, first power, constant. Okay, or the zeroth power, things like that. Okay, so now let's go combine our like terms. I'll simplify that. Negative 3n to the fourth plus a negative 11n to the fourth is a negative 14 to the fourth. 14, no, n to the fourth, not 14 to the fourth, 14n to the fourth. Then my second powers here, 10n squared plus a negative 3n squared is a 7n squared, so we have plus a 7n squared here. And then we have a plus 8n, and then plus a 7. And there we have it. We have our final answer here. Nice and neat, simplified. Negative 14n to the fourth plus 7n squared plus 8n plus 7. Negative x to the fourth plus 13x to the fifth plus 6x to the third, parentheses plus parentheses, 6x to the third plus 5x to the fifth plus 7x to the fourth. Okay? Now from here, since it's pretty much all addition, I don't need my parentheses anymore. I'm kind of going to do two steps at once. I'm going to eliminate my parentheses. I'm going to rearrange using my highest degree first. Okay? And we can't simplify anything in the parentheses because there's no like terms within the parentheses. So highest degrees first. Our highest degree I see is the fifth power. So I'm going to put 13x to the fifth first. And put a little dot to say that I got that. Then I have the other fifth power plus 5x to the fifth. Fantastic. See nothing else to the fifth power. Now fourth power. Highest degree is fourth power is next. So we have plus a negative x to the fourth right there, and I made a plus a negative x instead of subtracting x to the fourth. Then I have a 7x to the fourth right there, plus a 7x to the fourth. Okay. Now my next highest power is the third power. We have 6x to the third, and another 6x to the third. And I put little dots there to mark which ones I brought down. We should have everything. Let's double check. Negative x to the fourth is right there. 13x to the fifth is right there. 6x to the third is right there. 6x to the third is right there. 5x to the fifth is right there. And 7x to the fourth is right there. Highest degrees came first. Now we can simplify. 13x to the fifth plus 5x to the fifth is 18x to the fifth. And then negative x to the fourth plus a 7x to the fourth is a 6x to the fourth. Then we have 6x to the third plus 6x to the third is a 12x to the third. And there we have it. We have our final answer here, which is an 18x to the fifth plus 6x to the fourth plus 12x to the third. 9r to the third, and this is in parentheses, plus 5r squared plus 11r plus, parentheses, negative 2r to the third plus 9r minus 8r squared. Okay? So what I'm going to do now is I need to, I'm going to rewrite everything to be plus and negative, especially that down there. So I'm going to rewrite this, and in each parentheses, we can't simplify anything. There's no like terms. So we have 9r to the third plus 5r squared plus 11r. And I know this might be tedious, but we're adding here, so it's adding a negative to our third. It's tedious, but you know, it needs to be done. Just take that extra step doing it. Plus 9r, and then plus a negative 8r squared. Okay. Now I'm going to rearrange having my highest degrees first, highest terms first. So highest degree I see is the third power, so we have 9r to the third. I'm going to put a dot underneath it showing that I brought that down. Then we have plus a negative 2r to the third, and I don't see anything else to the third power. Next highest degree is the second power, so let's bring down the 5r squared right there. And the other second power is plus a negative 8r squared right there. And from there, I have my 11, my r's left, there's no more squared power, so it's just r, or second power, so we have 11r right there, and then plus a 9r. And I should have everything. Let's double check. 9r to the third is right there, 5r squared is right there, 11r is right there, negative 2r to the third is right there, 9r is right there, and negative 8r squared is right there. Brought everything down. Double check. All right, triple check actually. Use a dot system and then double check from there. So we combine our like terms. 9r to the third plus negative 2r to the third is 7r to the third plus 5r squared plus negative 8r to the second power squared is minus 3r, negative 3r squared. So we don't really need the plus sign there. I'm going to make that into, well, so it's a negative 3r squared. I just do a minus 3r squared because this is my final answer here. Then we have plus 11r right there and plus, oh, got to combine those two. Can't just write them down. Can't get too trigger happy there. 11r plus 9r is 20r. So 20r right there, and there we have it. We have 7r to the third minus 3r squared plus a 20r as our final answer. 13n squared plus 11n minus 2n to the fourth, close parentheses, plus parentheses, negative 13n squared minus 3n minus 6n to the fourth. Okay. From here, I'm now going to see within each parentheses, can I simplify anything? There's no like terms in each one. No. So now I'm going to rewrite all of this. Instead of subtracting, I'm adding a negative. If you know my videos, you know I like doing that. So we have 13n squared plus 11n, and we don't need the parentheses anymore because it's all in the addition, plus a negative 2n to the fourth, plus a negative 13n squared, plus a negative 3n, plus a negative 6n to the fourth, making all those subtractions be adding negative. So now I'm going to rearrange having the highest degrees first and bringing my like terms together. So I look, my highest degree is to the fourth power. So I'm going to go to the negative 2n to the fourth first. I put a little dot underneath it saying that I brought that down. Plus a negative 6n to the fourth was next. Okay, and I don't see anything else to the fourth power. Next highest degree I see, there's no third power, but there's something to the second power. There's two terms. So I'm going to add a 13n squared here. And then this one here, another one is adding a negative 13n squared. I don't see anything else to the second power. So now we just have a variable n to the first power. I see 11n, so I have plus 11n right there. And then plus negative 3n right there. And that should be it. Let's double check. Let's make sure we brought everything down. 13n squared is right there. 11n is right there. Negative 2n to the fourth is right there. Negative 13n squared is right there. Negative 3n is right there. And negative 6n to the fourth is right there. I've brought them all down. Fantastic. So two systems to double check, make sure when I rearrange the commutative property, everything was brought nice and neat together. So negative 2n to the fourth to simplify, plus a negative 6n to the fourth is a negative 8n to the fourth. Okay, got those two combined. Now 13n squared plus a negative 13n squared is just 0. So we have 0 right there, right? They eliminate each other. Then we have plus 11n. And then adding a negative, I always do that. Not just plus a negative 11n, we combine it with a negative 3n. So 11n plus a negative 3n comes out to be 8n. Okay, now we don't need the plus 0 in the middle. Okay, so we're going to rewrite this to be 8n to the fourth plus 8n. And there we have it. We have our final answer, negative 8n to the fourth plus an 8n. Parentheses, negative 7 x to the fifth plus a 14 minus 2x, and parentheses, plus, parentheses, 10x to the fourth plus a 7x plus a 5x to the fifth. Okay? Well, what I want to do now is I look into both my parentheses. Can I simplify anything? No, there's no like terms in either one. So now everything I see is subtracting. I'm going to add a negative. So I have negative 7x to the fifth plus 14 plus a negative 2x plus 10x to the fourth plus 7x plus 5x to the fifth. Okay. Now I'm going to rearrange using the commutative property, highest degrees first. Highest degree I see is the fifth power. So negative 7x to the fifth, and I put a dot, and I brought that down. The next fifth power I saw was a 5x to the fifth. So plus a 5x to the fifth. Put a dot there, okay, and I see nothing else to the fifth power. Now the fourth power, next one down, I see 10x to the fourth. So we added 10x to the fourth right there. Fantastic. See nothing else to the fourth. So I see the third power? No. Do I see the second power? No. This is the first power, x to the first power. So we have plus a negative 2x right there. And then it's plus a 7x right here. Okay, do I have anything? Nope, nothing else. First power. Constants left, just a 14. So let's do a double check now. I use my dot system, double check and brought everything down. Negative 7x to the fifth, 5x to the fifth. Fantastic. Oh, sorry, let's go 14. 14 right there. Negative 2x right there, 10x to the fourth right there, 7x right there, 5x to the fifth right there. Fantastic. So now we're going to simplify combine our like terms. Negative 7x to the fifth plus 5x to the fifth is negative 2x to the fifth. Then, do I have anything to the fourth power with it? No, so we just have 10x to the fourth. Nothing to combine there. Then negative 2x plus a 7x is a positive 5x right there, adding a 5x. Okay? And then lastly, we have a plus 14. And so now we have our final answer here. Nice and neat, simplified. Negative 2x to the fifth plus 10x to the fourth plus 5x plus 14. Parentheses, 7 minus 13 x to the third minus 11x, and parentheses, new parentheses, 2x to the third plus 8 minus 4x to the fifth. Okay. Well, what I like to do, I'm going to do two steps at once. Okay. I noticed that both the parentheses we can simplify within the parentheses, but I'm going to make all of my subtractions be adding a negative. I prefer them. So these, and when I write 7 plus a negative 13x to the third plus a negative 11x. Then I'm going to distribute this minus sign across. But when I do that, I make everything adding a negative. So subtracting a 2x to the third is adding a negative 2x to the third. Subtracting an 8 is adding a negative 8. Subtracting a negative 4x to the fifth is adding a positive 4x to the fifth. Okay? So now I have all addition here, and they're positive, negative numbers in different degrees. Let's reorder this to have the highest degree first. Highest degree is the fifth power. It's 4x to the fifth. So I'm going to write 4x to the fifth here. I'm going to put a dot underneath there to say that I've brought that term down. I don't see any fifth power, so we go fourth power, nothing to the fourth power, third power, I see 2. Okay? I have the negative 13x to the third, so we have plus a negative 13x to the third right there. I put a dot there, dot right here, the other one, plus a negative 2x to the third. I don't see anything else to the third, so next power, second power, nothing left. First power, 11, right? The negative 11x to the first power, so we have plus a negative 11x to the first power. And then nothing else with just x, so we have our 2 constants. We add 7 right there, and add a negative 8. Okay, double check the all went down, just making sure here. Put a dot there for negative 8. 7 right there, negative 13x, great, and negative 11x, fantastic. Negative 2x to the third, negative 8, and 4x to the fifth. Got them all. Didn't forget anything. No one was left behind. So now let's combine our like terms. There's nothing for x to the fifth, so it's right for x to the fifth here. Negative 13x to the third plus a negative 2x to the third is a negative 15x to the third. Nothing with just 11x, so we plus 11x here. And then 7 plus a negative 8 is a negative 1. Now I'm going to rewrite this, though. Rewrite it to have, instead of adding a negative, subtraction for the final answer. Kind of bring it back down with subtraction, make it look nice. So 4x to the fifth minus 15x to the third minus 11x minus 1. And there we have it. We have our final answer here. 13a in parentheses to the second power minus 6a to the fifth minus 2a, close parentheses, minus new ones, negative 10a squared minus 11a to the fifth plus 9a. Okay? Well, what I like to do, if you know my videos, I make all my subtractions through adding a negative. So here, 13a squared, adding a negative 6a to the fifth, adding a negative 2a. Then I'm also going to distribute that negative sign across. Negative times a negative 10a to the second power is adding a positive. So we're adding a positive 10a squared. Distribute again that negative, adding a positive now, positive 11a to the fifth, and distribute the negative because you're adding a negative 9a. Okay, we're distributing that minus sign across. Okay, so now I'm going to rearrange my like terms together in my highest degrees first. So the highest degree I see is to the fifth power. We have negative 6a to the fifth. Put a dot to bring that down. I'll show that I brought that down. Plus 11a to the fifth. Brought that one down. I don't see anything else to the fifth power. Next highest power I see is not 4, not 3, but 2. Okay, the second power. So we have plus 13a squared right there, plus 10a squared right there. Perfect. And now I don't see any, it's a positive 10a squared. I don't see anything else. So now let's go to the next one is just the a's. The negative 2a plus a negative 2a, and then plus a negative 9a. Okay, let's just double check we brought everything down. 13a squared, negative 6a to the fifth, negative 2a is right there, 10a squared, 11a to the fifth, and negative 9a. Good, we brought everything down. So now let's combine our like terms. Negative 6a plus 11a, or negative 6a to the fifth plus 11a to the fifth is 5a to the fifth. Positive 5a to the fifth. 13a squared plus 10a squared is 23a squared. Lastly, negative 2a plus a negative 9a is a negative 11a. Now I'm going to rewrite this to have, instead of adding a negative for my final answer, I'd like to have a subtraction sign. I find it easier to solve when it's adding a negative, and then I'll simplify, and then at the end I like to make it back to subtraction because it looks nicer. So we have 5a to the fifth plus 23a squared minus 11a. And there we go. Our final answer. 3b to the fifth plus 8b to the third minus 10b squared minus negative 12b to the fifth plus 4b to the third plus 14b squared. Okay? Well, what do I do from here? Well, I need to first I like to simplify within each parentheses, nothing to simplify. So now I'm going to make all my negatives be adding up positives. So we have 3b to the fifth plus 8b to the third plus a negative 10b squared. Sorry, added a negative. Then I'm going to distribute this subtraction sign right here to all parts. So negative times a negative 12b to the fifth is a positive 12b to the fifth. All right, positive 12b to the fifth power, not second power, fifth power. Distribute that here. We have adding a negative 4b to the third. And then the last one, adding a negative 14b squared. So now what I'm going to do is put all my like terms together in my highest degrees first. Highest degree I see is to the fifth power, so 3b to the fifth, with a dot, shows I brought it down. Next one here is 12b to the fifth, so we have 12b to the fifth as well. I don't see anything else to the fifth power, so I see anything to the fourth power? Nope. C to the third power? Yep, third power I see, 8b to the third, and then add a negative 4b to the third. Now, do I see anything else with v to the third? No. V squared? Yes, there's two of them. Adding a negative 10v squared here, and this one here, adding a negative 14v squared. So now we have all of our terms brought down. Let's double check. 3v to the fifth is right here, 8v to the third, right there. Negative 10v squared, 12v to the fifth, negative 4v to the third, and negative 14v squared right there. Okay. So now we have everything down. Let's go simplify our like terms, or combine our like terms. 3v to the fifth plus 12v to the fifth is 15v to the fifth. 8v to the third plus a negative 4v to the third is a positive 4. I can write a 4v to the third. And then lastly here, we have two negatives. Negative 10v squared plus a negative 14v squared is a negative 24v squared. Now I rewrite this as my final answer to that plus and negative with subtraction. So again, when I solve, I like everything addition, but for the final answer, let's move it back to subtraction. So we have 15b to the fifth plus 4b to the third minus 24b squared. And there we have it. Our final answer. 8b to the third minus 6 plus 3b to the fourth, next parenthesis, b to the fourth, minus 7b to the third, minus 3. Okay? Well, my first step, I always look and see if I can simplify within each parenthesis. I can't here. Okay? There's no like terms within each parenthesis. So now I'm going to take all my subtractions. I'm going to make it to be adding a negative. So we have 8b to the third plus a negative 6 plus 3b to the fourth, and then the subtraction I'm going to distribute as part of that. So distribute the subtraction of b to the fourth is now plus a negative b to the fourth. Again, distribute to the next one here. Two negatives make it plus a positive 7b to the third, and lastly, bring it up here, plus a positive 3. So now I'm going to rewrite this to have all my like terms together in my highest degrees first. Highest degree I see is b to the fourth power, so let's put the first one here, 3b to the fourth first, put a dot to show that I brought it down, plus a negative b to the fourth, right there. Then b to the thirds, so I don't see anything else to the fourth, so the thirds are next, plus 8b to the third, right there. And then last other b to the third is that 7, positive 7b to the third. Now, I don't see anything else to this third power, second power, or first power, just b, so now we have our constants, plus a negative 6, and plus a positive 3, right there. So now let's simplify. We're going to add our like terms together. Well, 3b to the fourth plus b to the fourth, or negative b to the fourth is 2b to the fourth. Then we have 8b to the third plus 7b to the third is a 15b to the third. Then lastly here, negative 6 plus 3 is a negative 3, which we can just write as subtracting a 3. And there we have it. Okay? So we have our final answer here, 2b to the fourth plus 5b to the third minus 3. K to the fourth minus 3 minus 3k squared, 3k to the third, and parentheses plus a negative 5k to the fourth plus 6k to the third minus 8k to the fifth. Okay? Well, what I need to do now is I'm going to, since I only distribute the plus sign across, so it's addition, I'm going to make everything be adding a negative instead of subtraction. So I'm going to rewrite this k to the fourth plus a negative 3 plus a negative 3 k to the third plus, and then here plus a negative 5 k to the fourth plus 6 k to the third plus a negative 8 k to the fifth. Okay. So now that I have all addition, I find it easier to now use the commutative property to rearrange. Let's put our highest degree first and put our like terms together. So highest degree first is to the fifth power, negative 8k to the fifth. Then I put a little dot to show that I brought that down. Now I don't see anything else in the fifth, so the fourth power is just k, so we have k to the fourth. And then here we have a negative 5k to the fourth. Okay. Then from there, I don't see anything else in the fourth power. Third power, we have plus a negative 3k to the third. And then plus 6k to the third, the other one. I don't see anything else to the third power. So lastly, I have a plus a negative 3 right there, plus a negative 3. Okay. I don't see anything else. No, we're good. So now let's go combine our like terms together. Okay. Simplify, or let's double check. Let's double check. K to the fourth was right there. Negative 3 right there. Negative 3k to the third right there. Negative 5k to the fourth. Right there, 6k to the third and negative 8k to the fifth. That second double check really doesn't take any time, or 5 seconds literally. Okay, but I just find it easier to make sure you can double check, and most likely you won't make a mistake and forget to bring something down. So now let's combine our like terms. I don't see anything else to the fifth, so negative 8k to the fifth is there. K to the fourth plus a negative 5k to the fourth is adding negative 4k to the fourth. Then our 3k's. Negative 3k to the third plus 6k to the third is positive 3k to the third. And then adding a negative 3 is the same thing as, well, let's break it down, adding a negative 3. Now I'm going to rewrite all my adding and negatives to be subtractions because I find that nicer. So we have negative 8k to the fifth minus 4k to the fourth plus 3k to the third minus 3. And there we have it. I changed my adding and negative to be a subtraction. So now we have a final answer, which is negative 8k to the fifth minus 4k to the fourth, plus 3k to the third, minus 3. Negative 10k squared plus 7k plus 6k to the fourth, parentheses, plus negative 14 minus 4k to the fourth minus 14k. Okay? Well, first thing I want to do is I look into both parentheses, see if I can simplify within it. I can't. So now I'm going to take all my subtractions and make them add a negative. So negative 10k squared plus 7k here, 6k to the fourth. Left side really doesn't change. Now we have adding a negative 14, adding a negative 4k to the fourth, and adding a negative 14k. So now what I want to do is I'm going to rewrite this using the commutative property and combine my like terms and put my highest degree first. Highest degree I see is to the fourth power. So 6k to the fourth, we write fourth, put a dot underneath it, should have brought it down. Add a negative 4k, k to the fourth right there. And I don't see anything else to the fourth power. I don't see anything in the third power, so let's go to the second power. I see we have negative 10k to the second power right here. Then from there, I don't see anything else in the second power, so let's go to the first powers. We have 7k and a negative 14k right there. Lastly, I don't see anything else with k, so let's go to the constants, and it's negative 14. There we go. Let's double check we brought everything down. Negative k squared, 7k right there, 6k to the fourth, negative 14 right there, negative 4k to the fourth, and negative 14k. So now we have that. Let's go combine our like terms and simplify this. So 6k to the fourth plus negative 4k to the fourth is just 2k to the fourth. Negative 10k squared doesn't combine with anything. And so let's go rewrite that to be subtraction. So we're subtracting a 10k squared. Okay. Then from there, 7k plus a negative 14k is a negative 7k. So let's go subtract a 7k as well. And then we have here adding a negative 4, just 14 is just subtracting 14. And there we go. We have our final answer looking nice and neat with subtractions. 2k to the fourth minus 10k squared minus 7k minus 14. Negative 7n squared plus 8n minus 4, parentheses minus parentheses, negative 11n plus 2 minus 14n squared. Okay. Well, what I'm going to do is rewrite, or see both parentheses. There's nothing inside I can't simplify, or I can't combine my like terms, because there's no like terms within each parentheses. So every subtraction sign, I'm going to make a plus and negative. So we're subtracting 7n squared plus 8n plus a negative 4. Then I'm going to distribute this minus sign across to all parts here. So negative has a negative 11n plus a positive 11n plus a positive, plus a negative 2. Distribute again across a negative plus a positive 14n squared. Then from there, I'm going to rewrite this to have my like terms together in my highest degrees first. Just the highest degree I see is the second power, so we have negative 7n squared. Brought that down, put my dot to show I brought it down, plus a 14n squared. The other one I saw, I don't see anything else to the second power. So now let's go to my regular n's, plus 8n right there, and plus 11n right there. Then we have our constants. I don't see anything else with n, so constants, negative 4 and a negative 2. So now let's combine our like terms together and simplify. So combine our like terms, negative 7n squared plus 14n squared is a positive 7n squared. 8n plus 11n is 19n. And then negative 4 plus a negative 2 is a negative 6. So we have subtracting 6 here. So make it subtracting instead of adding a negative. And there we have it. Our final answer being 7n squared plus 19n minus 6. 14p to the 4th power plus 11p squared minus 9p to the 5th, parentheses, minus, parentheses, negative 14 plus 5p to the 5th minus 11p squared. Okay. Well, from there, I want to see if each parentheses inside it can simplify. There's no like terms in either one. So now I'm going to rewrite all my subtractions to be add a negative and distribute the subtraction sign. So we have 14p to the 4th plus 11p to the 2nd power plus a negative 9p to the 5th. Then distribute the subtraction sign, subtract double subtractions, adding a negative, or adding a positive 14. And then here we're adding a negative 5p to the 5th. Distribute across here, adding 11p squared. Okay. So now let's go combine our like terms and put our highest degrees first. Highest degrees I see is to the 5th power. So we have a negative 9p to the 5th. Put a dot to show that I brought it down. And then negative 5p to the 5th. Next. From there, I have the next highest degree is 4th power, right? So I add a 14p to the 4th. I don't see anything else. So the 4th power. Then we go to the 3rd power. Don't see anything. 2nd power. I have a plus 11p squared, and the other one is just this other 11p squared. 2 of them. I don't see anything else p squared, nothing with p's, constant left, just 14. There we have it. Let's double check everything went down. 4p to the 4p to the 4th, 4p to the 4th, 4p to the 4th. Oh, made a little mistake here. That 14p to the 4th should be 4. Oh no, it's 14. It's 14p to the 4th. Sorry. Right, 14p to the 4th. I almost had a mistake there. 14p to the 4th is right there. Then we have 11p squared, negative 9p to the 5th, plus 14, plus minus 5p to the 5th power, and then 11p squared. Right there, fantastic. And that's why it's important to double check your work, because I almost thought that was a parenthesis, and it was 4p to the 4th, and I had 14 here, but in reality, there was the 1 there, okay? I just, for some reason, was thinking it was parenthesis. I'm like, oh, I didn't transfer it right. But it turns out I did, but it's good to always double check that, just have those things in place. So now let's combine our like terms here. We have negative 9p to the 5th plus a negative 5p to the 5th is a negative 14p to the 5th power. 14p to the 4th, there's nothing else to the 4th power, so we have plus 14p to the 4th. 11p squared plus 11p squared is 22p squared. And we have the plus 14, not 4, 14. And there we have it, our final answer here. Negative 14p to the 5th plus 14p to the 4th plus 22p squared plus 14. 8k plus k squared minus 6, parentheses minus, other parentheses, negative 10k plus 7 minus 2k to the 2nd power. Okay? Well, first thing I want to do here is I look in both parentheses. Are there like terms? No, there's not. So then I make all my subtraction to be adding a negative. So I have 8k plus, k squared. And then minus 6 is adding a negative 6. Then I'm also going to distribute this minus sign across. Negative, negative gives me a positive, plus positive 10k here. And we have plus a negative 7 here by distributing the subtraction sign, and then plus a positive 2k to the second power. Okay. Now I'm going to rewrite this using the commutative property with my highest degrees first and my like terms together. So I have k squared here. Put a dot, should I brought it down, plus 2k squared. Don't get squared, John. Then from there, I don't have anything else in the second power, so the first power of 8k, and then plus a 10k. Now I keep going. I have nothing else with k's, but I have my constants plus a negative 6 and plus a negative 7 right there. So now I brought my like terms together. Fantastic. All right, they're next to each other. So now let's go simplify. Let's combine them. K squared plus 2k squared is 3k squared. 8k plus 10k is 18k. And negative 6 plus a negative 7 is a negative 13. So let's go minus 13, and there we have it. We have our final answer here, which is 3k squared plus 18k minus 13. Parentheses, negative 9b squared minus 8u, and parentheses, plus a negative 2ub minus 2u squared plus b squared, and parentheses, plus negative b squared plus 4ub. Oh, just barely got it all in there. Okay. So what I have here is combinations of v's and u's and uv's. Okay. So what I'm going to do is, when I simplify this, I'm going to write the next thing, everything down with adding a negative. I find that easier. And in doing so, there's nothing, if we look within each parenthesis, there's nothing that I can simplify within each one. So we have a negative 9v squared plus a negative 8u plus a negative 2uv plus a negative 2u squared plus v squared plus a negative v squared plus 4ub. Okay? So what I'm going to do here is I'm going to have all my v squareds first, then my uv's, then my u squareds, then my u's. Okay? So you're still going to put your like terms together in the highest degree first, but then sometimes you put other things in between. It really doesn't matter fully, but let's just do that and have my v squareds first. So I have a negative 9v squared using the commutative property. Put a dot to show that I brought it down. Then I have as one of the v squareds, another v squared I see is just v squared, so we add a v squared right here. Then we have a negative v squared, brought that down, negative v squared as well. Put a dot to show I brought it down. Okay. Then my uv's, well, I have one uv here, so I have a plus a negative 2uv, brought that down, and I have plus a positive 4uv. Did I forget anything else? Just double checking. No. Then from there, okay, I'm going with u squared, so we have a plus a negative 2u squared right there. Don't see anything else. And then the last one's a negative 8u. Now, it really doesn't necessarily matter per se the order. Some teachers want all the highest degrees first, and then just keep going down from there. It doesn't matter. I wouldn't mark my student off for having this a little differently. But so let's double check. We brought everything down. Negative 9v squared here, negative 8u right there, negative 2uv, negative 2u squared, v squared, negative v squared, and positive 4uv. Fantastic. Brought everything down. Now let's combine our like terms. Negative 9v squared plus v squared plus negative v squared. Well, these two cancel each other out, so we're left with just a negative 9v squared. Negative 2uv plus positive 2uv is a plus a positive 2uv. Those are my like terms. Then we have just a negative 2u squared, so I'm going to make that a minus 2u squared, and then minus 8u. And there we have it. Our final answer here is negative 8v squared plus 2uv minus 2u squared minus 8u. Make sure I have enough room here. 4x squared plus 7x to the third y squared, close by parentheses, minus negative 6x squared minus 7x to the third y to the second power minus 4x. Next parenthesis, oh, just subtract them. Subtracting, parenthesis, 10x plus 9x squared. There we go, got it all down. All right, first thing I want to do is look in each parenthesis. Can I simplify anything? Okay, no I can't. There's no like terms in each set of parentheses. Okay, so now I want to make everything be added negative and distribute my subtraction signs throughout each parenthesis. So here, there's no negative, so we have 4x squared plus 7x to the third times y squared. Distribute that minus sign plus positive 6x squared plus a positive 7x to the third y to the second. Here plus a positive 4x. Now we distribute the next one, adding a negative 10x, and then adding a negative 9x squared here. So now let's go put our like terms together. So I'm kind of looking, scanning ahead. Don't just go all willy-nilly from the beginning. I see x to the third y squared, x to the third y squared. Okay, and the rest of them just have different degrees of x's in them. Okay, so what I'm going to do is I'm going to put the 7x to the third y squareds first. So we have the 7x to the third y squared. That's one of them. Brought the dot down. I put the dot there, so I brought it down. Plus this one here, 7x to the third times y squared. These are like terms, the same type of variables multiplied there. Then the next highest degree I see really is x squareds, right? I see plus 4x squared there. The dot brought it down, plus 6x squared right there. Then I have a negative 9x squared plus a negative 9x squared. Then from there, I don't see any other like terms or squared, so I got on the x's. I have 4x plus a 4x and plus a negative 10x. Okay, so it almost looks like it's more complicated here. Nothing really simplified, but what I did is I made sure I brought everything down. Let's use the dot method. Let's double check 4x squared right there, 7x to the third y squared right there, 6x squared right there, 7x to the third y squared right there, the other 4x right there, or 4x, I think not the other, negative 10x right there, and negative 9x squared. So now I'm going to combine my like terms. 7x to the third y squared plus 7x to the third y squared is 14x to the third y squared. Then we have combine our x squareds together. Well, 4x squared plus 6x squared is a 10x squared plus a negative 9x squared is just a positive 1x squared. Okay. Then we have 4x plus a negative 10x, and that's a negative 6x. And there we have our final answer. Nice and neat. This whole crazy thing came down to be this: 14x to the third y squared plus x squared minus 6x. Negative 5u to the third, v to the fourth, plus 9u, parentheses, plus another parentheses, negative 5u to the third, v to the fourth, minus 8u, plus 8u squared, v to the second power, and parentheses, plus, last parentheses, negative 8u to the fourth, v squared, plus 8u to the third, v to the fourth. Big parenthesis. Okay. So within each parenthesis here, there are no like terms that I can combine, because that would be like my first step. Okay. Don't see anything like that. So now I want to make everything that's subtraction to be addition or adding a negative. So, and then I would distribute, but I don't have to. So we have negative 5u to the third, that's a u, v to the fourth plus 9u, plus negative 5u to the third, v to the fourth, plus a negative 8u, plus 8u squared, v to the second power, plus a negative 8u to the fourth, v to the second power, plus 8u to the third, v to the fourth. Okay. So now I'm going to put my highest degrees first and my like terms together. So what I see is my, I assume u to the thirds, v to the fourths, right? U to the third, v to the fourth here, and then u to the third, v to the fourth. So, and here. So I'm going to put those first. So I have my negative 5, u to the third, v to the fourth, dot that I brought that down, as a negative 5. So that's one of them. Then I have another one here, plus a negative 5, u to the third, v to the fourth, brought that down. Keep going, take your time. U to the third, v to the fourth right there. Last one. 8u to the third, v to the fourth right there. And then I see nothing else that's u to the third, v to the fourth. Fantastic. So now I see my other combination ones. I have, oh, u squared, or u to the fourth, v squared. So I want to bring that one down, negative 8 u to the fourth, v squared, right there. Then I don't see anything else like that, but I see a u squared, v squared. So I have plus 8 u squared, v squared. Now I go by my other ones. I see what's left is 9u and negative 8u. So plus 9u plus a negative 8u. Take my time breaking everything down, or bringing them all down. So I did my dot method. Now it's really important to double check everything. Negative 5u to the third, v to the fourth is right there. 9u is right there. Negative 5u to the third, v to the fourth right there. Negative 8u right there. 8u squared, v squared right there. Negative 8u to the fourth, v to the second power right there. And 8u to the third, v to the fourth right there. So now let's go combine my like terms. Okay. Well, these two together, negative 5u to the third plus v to the fourth, plus a negative 5u to the third plus v to the fourth is negative 10. U to the third, v to the fourth. But I combine it with 8u to the third, v to the fourth, or all three like terms, gives me a negative 2, u to the third, v to the fourth. Then from here, do I see anything else that has u to the fourth, v squared? No. So let's bring that down, make a subtraction, 8 negative, or minus 8u to the fourth, v squared. Then I don't see anything that's u squared, v squared, so we have plus 8u squared, v squared. Then 9u minus 8u is just 1u, plus a positive 1u. And there we have it. We have our final answer here. Looks kind of complicated, but it's negative 2u to the third, v to the fourth, minus 8u to the fourth, v squared, plus 8u squared, v squared, plus u. So, let's double check. Yep, we're good. Got the answer. Negative 9x y to the third minus 9x to the fourth y to the third, parenthesis 1, plus next parenthesis 3x y to the third plus 7y to the fourth minus 8x to the fourth y to the fourth, and parenthesis, plus my last parenthesis 3x to the fourth y to the third plus 2x y to the third. All right. First step here, I look in both for all my parentheses. Is there any like terms that I can combine, or are there? No, nothing within each parentheses. So now all my subtractions, I'm going to do adding a negative. So we have a negative 9x y to the third plus a negative 9x to the fourth y to the third plus 3x y to the third plus 7y to the fourth plus a negative 8x to the fourth y to the fourth plus 3x to the fourth y to the third plus 2x y to the third. Okay, so now we're going to put our like terms together. The highest degree I see we have x to the fourth, y to the fourth. I'm going to put that first. So we have negative 8x to the fourth, y to the fourth. I'm going to put a dot underneath it showing that I brought that down. Then I see we have x to the fourth and y to the thirds. Okay, so a few of those. So I'm going to do those next. So we have first one here, adding a negative 9x to the fourth, y to the third. Any other x to the fourth, y to the thirds right there, plus the 3x to the fourth, y to the third right there. Okay, and then the next highest one I see here, let's just go with my y's, where I have a y to the fourth right there, so we have plus 7y to the fourth right there. That should mean then my next highest ones I see x to the thirds, y to the thirds, so let's go with plus a negative 9xy to the third plus 3xy to the third right there, and lastly plus 2xy to the third. And I should have brought everything down. Let's double check. Negative 9xy to the third is right there. Negative 9x to the fourth y to the third is right there. Negative plus 3xy to the third right there. 7y to the fourth. Negative x to the fourth y to the fourth right there. 3x to the fourth y to the third right there. And 2xy to the third right there. So now let's combine my like terms together. Well, negative 8x to the fourth y to the fourth is the only one that's like that. There's nothing else to combine. So we have negative 8x to the fourth y to the fourth. Negative 9x to the fourth y to the third plus 3x to the fourth y to the third. Those two together can be a negative 6. So we have minus 6x to the fourth y to the third. Then there's nothing else with y to the fourth, so we have plus 7 y to the fourth. Then we combine these here. Negative 9x y to the third plus 3x y to the third is negative 6x y to the third plus a 2x y to the third is a negative 4x y to the third. So that gives us a minus 4x y to the third. And there we have it. We have our final answer here, which is negative 8x to the fourth y to the fourth minus 6x to the fourth y to the third plus 7y to the fourth minus 4xy to the third. Y to the third minus 7x to the fourth y to the fourth, parentheses, plus a negative 10 x to the fourth y to the third plus 6y to the third plus 4x to the fourth y to the fourth, close my parentheses, minus parentheses x to the fourth y to the third plus 6x to the fourth y to the fourth. Okay? Well, what I'm going to do now is within each parenthesis, can we simplify? No. But now I'm going to rewrite this, making all my subtractions be adding a negative, and I'm going to distribute this subtraction sign across. So we have y to the third plus a negative 7x to the fourth y to the fourth plus a negative 10x to the fourth y to the third plus 6y to the third plus 4x to the fourth y to the fourth. Now let's go distribute the subtraction sign across, plus a negative x to the fourth y to the third, then plus a negative again, plus a negative 6x to the fourth y to the fourth. So now I'm going to put my like terms together, okay, in the highest degree first. I see x to the fourth, y to the fourth a few times, and that is my highest kind of, I would say, combination of highest degrees. So let's write the negative 7x to the fourth, y to the fourth here first. I put a dot underneath it showing that I brought it down. And this is important now to take your time. Nothing else to the fourth, nothing else to the fourth. Here, that one's to the fourth power, x to the fourth, y to the fourth. So we have 4x to the fourth, y to the fourth right there. Put a dot there. Don't see anything else. Don't see anything else. Oh, negative 6x to the fourth, y to the fourth. So we have plus a negative 6x to the fourth, y to the fourth right there. Boom. Next highest powers I see is x to the fourth, y to the thirds. So the first one I see there is right here, that negative 10x to the fourth, y to the third. Right there. Next, and I see another one here, plus a negative x to the fourth, y to the third. Then from there, I don't see anything else with combinations of x and y, so we just have y to the third and y to the third, so let's bring them down. So let's put a y to the third here, and then this one here is 6 plus 6y to the third. There we have it. Let's go double check. We brought everything down. Y to the third is right there. Negative 7x to the fourth, y to the fourth is right there. Negative 10x to the fourth, y to the third is right there. 6y to the third is right there. 4x to the fourth, y to the fourth is right there. Negative x to the fourth, y to the third right there. And then negative 6x to the fourth, y to the fourth is right there. Now we need to combine our like terms. Okay, so let's go. These three here all share the same x to the fourth, y to the third. So negative 7 plus 4 is a negative 3. Okay, negative 3 plus a negative 6 is a negative 9. So these come together to be a negative 9x to the fourth, y to the fourth. Okay, then I have my other like terms. So negative 10x to the fourth, y to the third, and the negative x to the fourth, y to the third. That combines to be a negative 11x to the fourth, y to the third. And then lastly here, we have just our y's left over. Y to the third plus 6y to the third is 7y to the third. And there we have it. We have our final answer, which is negative 9x to the fourth, y to the fourth, minus 11x to the fourth, y to the third, plus 7y to the third.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.